So this is for the thin lens lab. You guys built your optical bench with your light source and your lens and your screen, and you took two measurements. When the image got sharp here, you had to move things around. And when this got nice and sharp with that little crosshairs from here, you measured the DO from the object and the DI from the image, and you made a table, T-chart. When you graph those numbers, it should be curved in kind of an inverse function way. So it's going to be something like that. If it doesn't look exactly like this, don't worry. You just have taken different points. You might have points that are just up here or just over here, but it should be fine. This is just showing us that this is not linear relationship right at the beginning, so we have to linearize it. So we do 1 over all of these numbers. So this is Dariel's first point was 11 and 14. So if you go 1 over 11 and 1 over 14, and you do that to all your 5 points, you should see that that is a linear relationship. And the slope of this graph should be approximately -1. If it's a little different, that's okay. And this you're going to label as 1 over DI, and this is 1 over DO. So, if you think about a relationship of a straight line, what's the equation? Y equals mx plus b. So, we're going to get that, right? Now, our y is 1 over d naught, do. Our slope you should find is about -1, and that's going to be minus, and I'm just going to leave the 1 out of it because it's times this x. And this x is 1 over di, and then you're going to be plus some y-intercept. For a lot of you, this is like 0.06 or 0.04, 0.08 or something like that. It's a small number. When you flip it over, if you inverse this y-intercept, you'll find it's the same as the inverse of your focal point. So if you get your y-intercept and you flip it, it'll be close to the focal point that you measured. Okay. Now if we move this around, this happens to be a known relationship, but at some point somebody found this without knowing the relationship, right? They fiddled around and found out, right? You just tried to do mathematical things with this until you got something straight. So maybe they inverse 1, maybe they tried squaring it, maybe they tried whatever, and when they ended up inversing both of them, they found, oh, this is straight now. And it's a slope of -1. And so what does this y-intercept mean? And they compared it with the focal length of the lens, and they found that it's constant. So this is 1 over d naught plus 1 over di equals 1 over f. This is the lens equation. So if you just take this and add it over to the other side, you'll get the known relationship for the lens. So you guys can try that. You did it with 2 lenses, so if one lens doesn't work so well, don't worry. It's fine. And if this doesn't look so curved, that's okay too. You're just doing part of the inverse graph. Try to get your y-intercept from your linearized graph. Do 1 over that y-intercept and see if it links up to the focal length that you measured by the window. Now the focal length, if you held a piece of paper behind your lens and you get that nice picture from the trees outside, that distance will be twice your focal length because the image is coming through the lens and going like this. What do you notice about that picture? It's upside down. Yeah, because it's gone through the focal length and switched over. Okay. So if you write down your equations, the 2 equations from the 2 lenses from this graph, you try to compare it to focal length, you're great. You're good. And this is due, I think, on Monday for you guys. Maybe Sunday. My other class is Saturday. Sorry, Block 1-4. That's it. Any questions? Does that make sense? Kind of, sorta? Are we going to Playland? Yeah. You're so excited about it.